Okay.
Just give us a minute to start. So it's live and it's recording. Okay. Good morning, everyone. Welcome back to another day of this exciting workshop. This is day 10 of the 10-day workshop, and we are having the theme for the day is big data. Uh, Today we have with us Dr. Anurag Bagaria from Novartis, who is going to give the first talk and start the session. Dr. Anurag Bagaria has 13 plus years of experience in industry, startups, and academia. He obtained his PhD from Goethe University, Frankfurt, Germany in 2014. After a brief time as biostatistician at Siemens Healthineers, he returned to Goethe University as a scientific staff for software development. He's currently a data scientist at Novartis, India. It's a pleasure to me to introduce Dr. Anurag Bhatia, and thank you for taking your time to be with us. And I'll uh, let you start the session. Thank you.
Thank you, Raghu. So, thanks a lot. Thanks a lot, first of all. I think that's a wonderful opportunity that I have today. And I actually love to interact with students and uh, and kind of also I do take sometimes mentoring sessions for them. And it's a good morning, fine morning. Kind of excited. I am sure that all students that are hearing me today, and even others who might be seeing through this live video streaming, I would try my best to make sure that everyone tries and takes something with them from the talk today, at least from the whatever time we spend. So I'll quickly start sharing my screen. Yeah, I think I had that option. Yeah. Okay. So please let me know if you can see my screen. I think that's the wrong one.
Yes, we can see this.
Okay. Is it visible now?
Yes, it is, but it's not in the slideshow.
Does it appear better now?
Yeah, I can see the screen.
Okay. I think it will start this way. It could be just a syncing problem.
Okay, I think we can start. So it's a civil slides visible, so just it's not on the slideshow. That's all. Otherwise, it's okay.
So yeah, so today I'll be talking about basically intersection of two fields, right? That's biology and big data. You might see this star there in front of biology. So basically, what that implies in my today's talk is I would want to give a different flavor of biology, right? And by different flavor, I mean it's more about uh, the application side. It could be in terms of the clinical biology. It could be what actually how biology is applied in the industry at the end, right? Um, and yeah, and basically it's more like at the application level, how businesses run on that, how companies are set up on that, what can be the opportunities around that, what can be kind of uh, businesses or startups that people start just based on biological data, right? So I would not want to go into stuff like what's happening in the labs, what kind of researches happen there, though I would very briefly set up on, touch on those things, right? So it will be just kind of a very different flavor, different angle to how you see biology, and also, yeah, and how that interacts with big data, and how is that useful. Okay, and before we actually begin, that's like kind of a part of my compliance, working at Novartis. But whatever I present today, I would just like to mention these 4 points quickly. They are legally and by compliance, they are important for me to mention. Whatever I talk today, the views presented to you all are my personal views, just based out of my understanding of the industry, how things run. And all that material that I will be presenting today, again, are the content I've gathered from the internet, all around wherever I could find something relevant. They are not my original content, except that the story that I've put up together. And I've tried my best to place in whatever sources I've to kind of acknowledge them out there. And this talk is purely for educational purposes. And during this, whatever I speak is kind of general industry practices and examples that I'll be taking. It has nothing to do with my current employer or any of my previous employers. So having said that thing, I'll quickly come to my next slide. And uh, basically, uh, in today's world, we keep hearing a lot of buzzwords, right? By buzzwords, what I mean is when you talk about industry, so there are a lot of things happening in the industry. It could be any industry: pharma, finance, automobile, retail, banking. It could be healthcare, right? Uh, but then all across, you keep hearing some common buzzwords. Let's try to basically use this as a kind of interactive one to just, and also use this as a icebreaker to get some inputs from students. What kind of buzzwords do you keep hearing around big data and stuff? Is there some problem? Hello? Yeah. Sorry again. Acha, okay. So do you want to start again? For me, Zoom is working. Okay. Yeah, it's fine. Yeah, please just let me know. I can kind of restart. Hmm? Okay. Okay, it seems there's some network connectivity issues. We'll try to wait for some time till that's back. For anybody who is hearing me.
Hi Anurag, can you hear me? You may not be able to see me, but can you hear me? Can you hear me, Anurag? Oh, you are on mute. You have to unmute. Yeah, can you hear me now,
Yeah,
Anurag?
am I audible?
Yeah,
Am I
I'm
audible?
audible now. Yeah, you're audible. Okay, so live போயிட்டு இருக்கு. திரும்பி பண்ணுமா?
I'm trying to find where I am.
Huh? Fine now. Okay. Yeah. Okay. Just click record here, and then you can start. I think we were just on the first slide, and then sorry about that. Sorry.
Yeah, should we start over again?
You'll have to share your screen, Anurag. You are on mute again. No, you're not able to share my screen. Is it? Oh wait, no, it is that. Yeah.
Yeah. Okay, I'll quickly start sharing.
Yeah.
Right.
Yes, we can see your screen, Anurag. Yeah.
Okay, I'll try to start over again. I'm not sure if people uh, have yeah, so same and privilege to have me here, and I'm happy to be here. Quickly to make also good use of the time that we also kind of lost. So all that I present today, they are my personal views, right? And they have nothing to do whatever my current or previous employees have been doing, or they do even today. The content that I present again today, that's all collected from the internet, and that's not my original content. I've tried my best to put in the sources from where I pulled them up, and yeah, this talk is completely and purely for educational purposes. So it's just for the understanding of the audience that's kind of hearing me out, and the topics that I cover and the examples that I bring in here, they are general industry practices, and they should not be kind of correlated with whatever my current company does, or any of my previous employers they do or have been doing. So that's kind of important, just from legal compliance point of view. I just want to make sure that it's not taken in a different context. Um, right. So am I, just to kind of a cross check? Am I clearly audible and things are like okay? Hello.
Yes, Anurag.
Okay, great. Yeah, nice. So yeah, so this is about something about I would like to use this as something like a icebreaker to get some inputs from the students and people out there. We have been hearing a lot of buzzwords all around, right? So especially I'm talking about in context to the industry. So when you hear about big data, the lot of technologies, new things coming up, digital things there, internet, the new businesses, Google, Amazon, Facebook, all those things, right? So there are a lot of buzzwords that you keep hearing around. So one thing can be like big data. So let's hear some or see some buzzwords that might be interesting to you, that comes to your mind. And basically these words are something which are cool, and you kind of talk about them, you read about them,
Anurag,
and they're Yeah.
Anurag, sorry to interrupt. We can see your slides, but it is still on the first slide. So we don't see the slideshow. We are seeing the yeah. I think.
Okay. How do I change that?
I think you have selected only the specific window to share. What you do is like you select your entire screen to share, which is the default in Zoom, and then you can go to slideshow, and then we can see your entire
Okay.
screen. So
I'll
that
try
will
that.
probably stop
Wait.
sharing and then start sharing again.
Right. I'll do that.
Yeah, now we see the third slide, buzzwords. Yeah.
Great. Okay. Is that better now?
Yeah, it's better. Yeah.
Yeah. Sorry. So let's hear out some buzzwords from students around there. Uh, can you put in some things in the chat window so that I can see that? I'm not sure if I
So
can see the chat.
participants are allowed to talk, so they can unmute themselves and then they can talk to you directly also.
Okay, that's great. So let's hear out some buzzwords that come to your mind. So I'll give you an example. That's like obviously the topic of the day today, right? Big data is one big and nice buzzword. That's cool. People love to talk about it, and it's impressive when you talk to somebody that you know something about that. So if someone doesn't want to speak, we can also just put it in the chat. That's fine.
Drug design.
Okay. Sure.
Clinical trials.
Nice. Yeah. Good.
Docking. Reverse docking.
Sorry again.
Reverse docking. Reverse docking.
Reverse.
Docking.
Reverse docking. Okay. 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 So I what the all the three words that I just heard, they were basically coming in from, I would say, around the biology area. Let's hear out some words also from the technical areas. So other thing could be like somebody might have heard about something called digital twins. Anyone has any idea what that means?
What is it you said? Digital?
Digital twins.
Digital twins. Oh, okay.
Well, so these are like I would say kind of nice buzzwords. I mean, digital twins. I'm just kind of using it now. Um, Not that I'll be kind of speaking about it. I mean, these are some things which are like really like the cutting edge kind of areas in the industry, which people are kind of working, I would say, under the waves. So nobody really talks much about it. It's about technologies where, for example, uh, you can imagine as if sitting in a room and using just your hand motions, and a robot or somebody at somewhere else, like somewhere it can be thousands of kilometers away, makes the same movement that you make sitting in the room and gets a job done. So something of that sort. So it's like really something imaginary. I mean, it's difficult to believe that's going to happen, but people are working on that. So now I'll just quickly, to put the context of today's talk, I'll bring in some words here. Not many, just a very few. So I'll spend some time. So big data, obviously that'll be quite a kind of a major chunk of the talk today. I'll not talk now, but I'll cover it up soon. Data science is again another buzzword, right? So it's all about getting hold of all possible data, trying to define certain problem that you can solve using that data that you have. For example, somebody could be collecting, I mean, in terms of biology, could be collecting data from the genome sequences, right? But what do you do from that? You have something like uh, uh, a long chunk of that sequence, but can you try to make sense of it? Can you pull out some information out of it? Can you use that information in some way? Can that be used to cure certain diseases? Can that be used to set up a business? Can you earn money out of it? If you know to do certain uh, actions on that sequence, can you get a job? That's all about, I mean, so basically it's about getting the data, tweaking it in some way, beating it around, bashing it around, getting some information out of it, and then kind of selling that information out, right? That's how I put it, that data science. I have a separate slide on that. I'll kind of go deeper in that. So next is another cool word, AI ML, artificial intelligence, machine learning. These are again based on technologies, the way they have evolved, right? And uh, that's given us a lot of power. Again, that comes with responsibility, not that you can just do whatever things you want and then go out and present it. That's cool. I mean, just because it's cool, it's not that you can sell it, right? Like automated cars that run autonomously. You cannot just go out and start running them on the roads, right? You have the data, you have the visuals which get captured. There's a lot of analytics happening, and the cars are ready to run. But there are a lot of compliances, a lot of accountability which comes with it. Only when we are sure we can actually go and allow that to happen, right? Who takes the responsibility? IoT, again, cool word, right? Internet of Things. So basically, one device speaking to the other. So can imagine, I mean, the very basic thing or very real thing that you can actually, you might have seen already is like something like you have your mobile app, and using that, you can switch on your light, which is again connected to the internet. I mean, that's something already on the ground, easily available in India today. So I'll just give that particular example right now. But then there could be many others. So at least what I know, people are trying to have cars talk to each other. What do I mean by talk to each other? Is like data from one car is getting sent to a server, and that's kind of distributed to the next car. So as to know, okay, there is a certain traffic jam happening, or there is some sort of a log pile on the road somewhere in the front, and then that's kind of helping to take certain decisions, right? Industry 4.0, that's again a new, I mean, it's not really new anymore, but it's there for half a decade or at least already. That's about once you have standardized manufacturing process in the industry, you just want to replicate it. You don't want to do that kind of management and operations, like doing it normally in the regular way, because it's standardized. It's just it's done. So essentially, one of my early advisors used to say, anything that's done repetitively, anything that must be automated. And I think I kind of agreed with him in most aspects, except that one point, there could be certain things which are too much attached emotionally, right? And people may not want to automate them. Like if I love to cook, I would still want to do it, even though it's repetitive, right? So yeah, but that's going away from the topic. I'll quickly take some and get into the next thing. I'll just kind of explain 2, 3 of these words, but in a bit in detail. We've heard about artificial intelligence. So is this something which is new, or is it something that we have only started hearing recently and it's not new? So what you see on my slide is that artificial intelligence has been in existence for over half a century, not like a decade or half a decade. So there have been a lot of work. I mean, right from the inception stage, kind of trying to come up with ideas, bring in some mathematics around it. So that was more of a research stage, and that's kept on evolving. And what you see now today, and based on what we actually start to hear about artificial intelligence, is the application of it. It's more of the application that you actually hear, because only when things move to the applied area, people start talking about it, start selling those things and market things, and that's how we get to know about it. And that doesn't mean that it didn't exist earlier, right? And it's with everything, whether it's business, even for example, you put that in context of the COVID vaccines that we have today. Typically, I'll be talking about it again, but then typically a drug development takes about 20 years to get a successful drug. But this particular vaccine has taken lesser time. But does that mean it has just come up within a time span of less than a year? No, there's been a lot of work behind it from several years behind. And it's only now that we see that. So that's about artificial intelligence. Now, next thing is when you talk about data scientist or data science, this is something I like to share and discuss. So, people have a lot of notions about what a data scientist is. What are the skills that a data scientist needs? I love this particular definition of a data scientist. I mean, there is something called as Drew Conway's data scientist, where he says, so you see on the center towards the slightly above that, Drew Conway, that's the Venn diagram which covers business, programming, and statistics alone, skipping out the communication part. Um, and in my mind, and at least what I believe, it's all four, including the communication part, and that's the perfect data scientist that we need today. So it's about being able to understand the business, at least a part of it, apply the statistics to understand, to do the experiments and experimentations and descriptive analytics of the data, write the programs, run the models, and get some insights. And not only that, you don't have to stop there. You actually need to go out and sell it. It's only then when you are able to actually get that complete package, right? So that's what I mean by the perfect data scientist in this particular Venn diagram. And yes, this particular concept has been given by Stephen Kolasa. He's the guy who I think he works with, I guess it's SAP. Uh, I need to, I'm not sure, but yeah, so that company. So yeah, that's the definition that I talk about. Now coming to more, getting to the topic now, right? So we talk about big data. So what's your idea about big data? What does it mean? Where does it come from? How does it look like? So big data, as you can see from this photograph, is basically uh, it's all kind of data that's constantly evolving from all different sources. It could be through just a single click of a button on Facebook. You press a like. Now, what's the impact if you just press a single like button on Facebook? It's basically giving an information what kind of location you are in, the geographical area, right? It also gives the IP address of the system. It gives um, the kind of the sentiment in a way. It gives if you're able to track that person, you can tell what kind of posts he likes, what kind of things he likes, right? And so it also gives you the information about the ISP, the internet service provider. So that's all information going in just by a single click of button, simple pressing a like. Now imagine if you comment or if you are sharing a photograph. That's all information. That's all kind of, I mean, not information, it's slightly different from data, but that's all data, right? And you keep on collecting data, and what that leads to is, if you analyze, if you have the right tools and skills to analyze, that leads to a certain information that can be again useful. It can be used for uh, multiple purposes, right? So that's what I mean by big data, and this is huge, right? And these data can be of several kinds. They can be structured, unstructured, semi-structured. What I mean by that is, so structured is, let's say, imagine something like an Excel sheet, right? You have structured it, okay, names, age, location, so on and so forth. You can structure it in a certain way. It could be just numbers, right? So it could be the marks of students in certain subjects, right, for a particular class or particular college. So that's structured. Okay, you know the range is between, I don't know, could be between 0 and 100 and so on. Unstructured is like, mostly it's about, you can talk about videos, you can talk about audios, you can talk about images, you can talk about text, right? So these are kind of unstructured data, which it would not have a defined length. It may not have a defined structure to it. It's just freely flowing kind of data. Semi-structured is something, uh, it's kind of something in between, where you have tried and kind of managed the unstructured data in certain ways. So you have IMS, which is like information management systems. You could be storing certain the data in certain formats, even if it is the text data. You could be storing them in certain file formats, JSON, CSV. I mean, these again may sound kind of alien words, but then these are certain formats which you actually get to store the data. CSV is like comma separated files, values, right? That's also possible to do it in Excel sheet, Microsoft Excel. Then it could be things like data from retail stores, could be from markets. So you imagine like something like a receipt that you get from the big bazaar or a similar retail, right? So what you see there, it's text on that receipt, which is kind of, in a way, it's unstructured, because somebody could be buying just 2 items, somebody could be buying 200 items, but then that's kind of unstructured, but there is still a structure to it. So you have the name of the outlet, the location, at the same place, there is the invoice number, and so on and so forth. So there is some sort of structure in that unstructured data, right? So can you imagine that way? So now this big data, right? This data, as I said, is huge. It's constantly evolving. What do I mean by evolving? That's my next slide. These are some numbers. I mean, frankly speaking, I've not even given a deep look at these numbers, but just by the view of it, what you see is that's what is happening each minute of the day, each second of the day. I mean, each hour of the day. It's constantly evolving, and there are businesses, there are people who have stakes, and they are constantly trying to capture it. Why do they want to capture it, right? That's again a question. How do they capture it is again another question. Once they have captured it, what do they want to do it using that data? Is it useful? Or yes, I mean, yes, there are billions of dollars of money which is floating around, and it's running around just based on this single, I mean, as simple as a click that you do on Facebook or Instagram, right? So this data never sleeps. It's constantly evolving. And now what I would want to go is into, slowly go into kind of the pipelines, how this data is managed. That's my next slide. And this is like a very high level. Uh, so as to understand, so this is like a pipeline, right? Pipeline is basically you are trying to collect the data from whatever source you get. And once you've collected it, you want to kind of make sure that you store it in certain ways where uh, where uh, um, on your systems in some sort of databases or data lakes, you call them, um, so that they can be utilized in certain ways that you want, whenever you want, right? That's the ingestion part of it. Preparation is like, even using that huge chunk of data that you've stored somewhere, you want to prepare it in certain schemas, certain data structures, and uh, and kind of make it ready for further processing immediately. So why this is kind of broken into different parts is kind of to make the job easy. It's kind of, I would say, very difficult for a single person to do it end to end. I mean, there could be a complete company just kind of working on this individual slice alone. So you see like 5 slices there, and there could be individual companies just floating around just on the each slice of it. So preparation of data is there, and once the data is prepared in certain data structures and all, you could run the descriptive analytics, you could do the experimentations, you could do the computations, you could run models, try to get some insights, right? So that's the fourth part. And once you have that, you can go out and present that, sell it, market it, right? So that's how the whole data is managed. And that's the pipeline that you see. So that's like a very generic uh, thing that I show about how this big data is managed. Now, to put that in perspective, and also in terms of certain, I would say, tools and technologies which are important from job perspective in the job market, right? Uh, there are, for each of these slices that you see on the screen, there are very big players like Amazon, Google, and Microsoft who are playing. They have customized solutions for it, for each slice of it, right? There also we have kind of a lot of, I would say, open source tools and technologies. You might have heard about Hadoop, Spark, uh, MongoDB, right? So I'll just to give that in a put that in a context. My next slide is about the same pipeline, and you have customized solutions from all three major players. And these are like paid services. I mean, you can have the initially you could try them out for free for, I mean, certain amount of time at certain limited volumes that you want to play with. That they follow something like a freemium uh, model. Freemium is like a mix of free and premium, right? So that to get people started, that once they start using more and more often, then they start to pay out, right? So even frankly speaking, all the names that you see, right? For, let's say, in case of Amazon, you have this Lambda function. That's basically how you ingest the data from where you get it. Then you store them into data lakes like S3 glaciers. Then you do use next things is like extract, transform, and load. ETL. That's a very standard word in the data industry. So there you have different again tools for that. SageMaker. It's again kind of important, very kind of cool tool to know technology today. It's kind of very cool for the jobs. And then you have Redshift, where you can basically where the data is again stored for immediate pulling out, for doing whatever computations you want to do or analysis you want to do, right? and and then finally you want to go out and present it to the stakeholders. It could be to the audience, to the buyers, or in terms of a startup it could be to investors, right? And and that's about something like a quick site. Now parallelly you have similar tools and technologies coming in from Microsoft and Google. And all these words, or the names of technologies, right? They are changing constantly. I mean, people are replacing it. They are bringing in better versions, something which kind of gets the job done, right? And it's kind of enabling that whole data management. So if you would have asked me like a decade back, what does data management look like, or let's say 15 years back, when I was kind of at that point of time when I got to know Raghu, data management would be something like pulling data from the internet, like downloading it and storing them in certain directories on your computer and running some scripts on it. But this is just magnanimous. I mean, it's just to put that again in context. Data warehouses of Google could be as big as 10 football fields, right? Just kind of having those servers where those data are stored and managed. Uh, so basically, what I mean to say is these are tools which are very important, and even in the industry, if somebody works on SageMaker, it's very often that people would be looking for a person who has an experience in SageMaker already. But then, let's say, or let's say something like we have something like a data IQ, somebody who has worked with on data IQ. But then, if you don't find somebody, you could go to a person who has a similar experience on technology from Microsoft, which is like something like a Databricks, right? And they would know, okay, this person has some experience in that. I could hire him, and he could be quickly trained if he's trainable, and so on. Similarly for Google. So I in terms of Google Cloud, I think I worked on Google. I mean, this big query stuff. That's so fast. If you want to do some queries, I mean, something like SQL query or some query that you can do through MongoDB. MongoDB is again kind of a database management kind of thing where you can store your data. You can pull the data with using the queries and do whatever analytics you want to do. That's again, that thing is actually open source. You can just build it over your own systems. That's possible. But these that you see on the screen, they are customized solutions from these companies, and there are many more actually. So these are just big names. That's why they are here. But there are also smaller players, and you could do it also yourself. So imagine a startup, right? They may not be able to afford these, so they might be starting with very small amounts of money, and they would want to maybe just quickly try out. Obviously, just for trying out, they could the services. Some of these services are free. They could start doing that, but then even for a larger thing, they might want to assemble certain things from the I mean the open source stuff, Hadoop, Spark, and so on. So that's what it is. Now that you have managed this data, okay, you know, to get it, store it, kind of. I mean, this thing is there. What do you do with this data, right? That's the big question. Uh, so let me take a pause here just to get some thoughts and from the students. So you know, just to make sure that my language is kind of understood and I'm not speaking French here. So let's get some thoughts. So once you have this data, what do you think we can do with this data?
We can actually do analysis to solve some real world problems. Uh,
Okay, and what do you mean by solving problems?
so since we are from the mostly from the biology background, I'll go with the biological part. Say, people, experimentalists,
That's okay.
people will generate enormous amount of data, but so we can use these approaches such as machine learning to sort of reduce the cost in the drug discovery process in lead optimization techniques, and that is how I believe the machine learning approaches on all the data generated are very very useful.
Yeah, that's, I mean, great. That's a good point. Anybody else?
So from data, we can generate some algorithms. Like being from a clinical research background, I'm doing pharmacology. So, like if I am doing pharmacogenomics, then we can develop some pharmacogenomics algorithm for a particular population, like for North Indian population, for South Indian population, for a specific research.
Right. And so you know there is some difference between a certain cohort. So it could be from India or Africa. How do you make use of it?
Sir, your voice is breaking.
Okay, that could be a connection issue. So okay, so let me instead of asking a question, let me try to kind of explain it. So now that you know that there is a certain difference between two different cohorts, right? So uh, the genetic difference, there is a genetic difference between the population of India and let's say Africa, for example. So can that be information used in certain way?
Yes, sir.
Obviously, yes. I mean, right? So if you have a certain drug, certain molecule, I mean, it may or may not work in the same manner for both the populations, right? You might to have
Yes, sir. Exactly.
some tweaks in that molecule. You might want to have uh, a different kind of treatment, a different course of different whole thing changed together, right? Um, so so right so it could be completely so basically that's from the application point of view, right? Again, so basically that's what we do. So now to put that in a context again, that's my next slide. So how does it help? And so I've just mentioned 5 points here, but then there could be many more, right? It could be cost saving, I mean that's again resource, right? So and these 5 points that I've mentioned here, so you can get insights from the data. What I mean by insights is again, as you just mentioned, right? Genetics data, you want to see some mutations somewhere. Does that mutation kind of lead to certain kind of disease? Can that mutation be targeted in certain ways so that that disease can be tackled or managed in certain ways or can be avoided in certain ways, right? That's the kind of insights we're talking about. Then bias-free decisions. Bias-free decisions is like once we have, let's say, a data for 5 patients, and there is a data for 500,000 patients, 5 lakh patients. 5 patients data is something which can be uh, easily checked, and maybe you can make some decisions based on that. A doctor, for example, who sees patients on a regular basis, in a span of 2 3 years, he could have seen 5 patients who have a very similar kind of history, right? And based on that, he could make a decision. But then, let's say, not one but 10,000 such doctors have been seeing 5 patients that way, and we kind of assimilate that data and get a broader bird eye view of what that data looks like, and that becomes statistically more significant, right? Because you could be biased just by seeing the data of 5 people, but then if you do it for 5 million or 500,000, that's a different story altogether. So the decisions can be unbiased, right? So similarly, in case of how do you allocate your resources, where do you put your money, where do you put your time, where do you so any kind of resource that you have, right? Should I be let's say if you want to analyze you have like millions of data points in even in terms of genomic sequences, right? Which is the direction you want to go, because the possibilities are endless, they're limitless, right? You cannot be just keep on researching and trying to solve things, but then you need to slowly funnel out into a certain direction which leads you to something which is promising in terms of the rewards that you get from the time and resources that you've spent, right? So that also helps in resource allocation. Risk mitigation is again something you get to know if you get to know of a problem in advance, before time. So if you know that this is not going to work, let's say a year in advance, you save the time. That's more important than the money, right? You want to spend that time to maybe look into a different direction. That's kind of mitigating the risk. You can take examples from totally different industries, right? We have cool things already happening on the ground. It's not just like imaginary world. It's We have something called predictive maintenances, right? You have windmills running, and we have sensors placed in there, and you have data which is getting collected constantly every second based on dozens of different sensors constantly, and we know that there are certain parameters, certain kind of ranges in which these each of these data points should be falling in. But let's say one sensor starts reporting that the temperature is going up. What does it mean? You could be sitting like thousands of miles away just by seeing that data. You don't have to wait for the machine to break down. You could just go on a phone call and send the engineer, and the engineer doesn't have to stay there for all the time. So for example, offshore windmills, right? You don't have to be in the sea all the time. You could be at a nearby station, and somebody just goes there when that data point is kind of triggered, that flag is triggered, right? So that you are maintaining in a predictive manner. So even before that breaks down, you have the time to go and replace that part and check what's the problem. You have the predictive maintenance in railways in certain countries. What does that mean is, uh, in the normal scenario, when an engine, for example, breaks down, you might have the whole train stuck on the rail, right? I've experienced such case. I'm sure some of you might have done that. So in France, right, we were stuck on the line for about 2 hours, unless the next another engine was called up and this train was pulled again. But then what's changing now is you kind of place sensors, and there are some obvious problems which can be just based on the flags raised by these sensors, they can be detected. So you don't have to constantly keep spare engines positioned somewhere, which means again decrease costs. It's not only mitigating risks, it is decreasing costs. So earlier you might want to keep like 10 spare engines to pull those trains, but now just two would be sufficient, because there are less breakdowns on the run. Maintenance can be done when the train is when the engines are parked somewhere for their regular wash or whatever, right? So those things are possible. So I mean, there's so many different examples in the industry. So strategy planning is again, so when you have some insights, okay, that is something coming up, that's quite promising. How do I align things already with my stakeholders? Can I go start having the discussions already? Can I think of having something down the line, 2 years down the line? Who can plan long-term strategies based on that? And these 5 things that I mentioned here, they are kind of very, very generic to any industry, right? So whether I mean, take it any, so finance, healthcare, pharma, automotive, retail, banking, oil and gas, everywhere. So I can give you another example from oil and gas, right? So just based on image analytics from that satellite. So you might have seen those huge containers, huge stores where the oil is placed, right? So just based on the shadow, right, the level to which the oil is filled up in those big tanks, there is a corresponding shadow which falls inside the tank, right? Just based on how high that shadow is in the tank, the image of that getting captured and processed, one can say how much the tank is full or how much is not. I mean, how much is there. Somebody doesn't have to constantly climb up that height It's just purely taking the photograph, processing it, and telling, okay, that's the kind of volume there, and based on that, continuously that's fed into the system, and it goes to the already the purchasing team, right? They know what kind of volumes of oil to be purchased across the country. So that's image analytics. So image comes also in healthcare. So you want to identify uh, kind of, I would say, MRI scan images with patients who are kind of diagnosed with certain kind of disease, right? There could be some commonalities over there which you would want the algorithm to learn, the models to learn. And based on that, you would want to feed that into the model and and so that it can tell you whether, just seeing that image, whether the person has uh, that problem or not. And interestingly, the error rates in these predictions have been found to be much lower than the errors committed by expert doctors. Isn't that credible? That's purely based on data analytics, right? So now again, so these are so many things which can be done just based on analytics of the data, right? Now I'll try to put that into a better context, bringing that to slightly into a biological flavor. Okay, so that's coming to my next slide, kind of differentiating between preclinical and clinical research. Okay, so now what you see on the left kind of um, depicts the preclinical stage of research, and on the right is clinical research. Now, somebody or any one of you would like to tell me what do you, at least from the photograph, even if you don't know already, what is the difference that you can see? What's the main difference between preclinical and clinical research?
The subjects used.
Absolutely, great, right. So that's kind of also clear from the image, right? On the left, the preclinical stage is the stage when you do all kind of experimentations on non-humans, right? It doesn't happen on humans, okay? So it can be different kind of animals. It could be just tissues, cell lines, all that sort, okay? That's the time when any particular biochemical, if I call that, or a drug, or a molecule, or a perspective drug, has never entered a human body. That's the preclinical stage. So it could be in vivo, it could be in vitro. It could be in the body of an animal, it could be just the cell lines. Okay. Clinical stage is when that's the first time when the molecule is introduced into a human body. Okay. And there are a lot of risks before you introduce any molecule into the human body. You need to be absolutely sure that it's not going to cause troubles. I mean, that has a lot of repercussions. I mean, if you can just correlate with what you might have recently seen in the news, right? Just by a small or a single event of AstraZeneca vaccine creating some issue in one particular patient, all of a sudden there was a lot of hue and cry. There was the stock markets for that particular company. All of a sudden, kind of the stock for the company actually, right? They were impacted quite a bit, for at least for a certain amount of time, right? That has implications on money. It has implications on the policy. It has implication on the people who are responsible. I mean, people could be fired from jobs because they were kind of hired because based on the success or the probability of success of the thing, right? So there are a lot of things happening there. So that's the kind of, I mean, one is looking at from the sense of biology as it is, and the other thing is kind of the applied part of it, the how it actually happens and runs in the real world, right? So that's about now. Okay, so having understood this, how this is different, right? Now I would want to talk a bit about the drug journey, right? Somebody earlier mentioned about drug discovery. So this is my next slide, and I'll be talking about how does this drug development process look like. And as you see, this is like a funnel-shaped process. It's a long process, and it's a tedious process. It involves time, money, patience, whatnot. And at the end, there are more failures, much more failures than any success that you can expect, right? Uh, so we can start with as high as like n number of molecules, funnel them down. A lot of them are kicked out at the drug discovery phase itself. Preclinical studies, when they are introduced into cell lines, it could be through animals and whatnot. And then there is a stage when you go for something like you file it for a IND, which is like an investigational new drug. That's even before you actually want to even try it out for the first time on human beings, right? You need to have certain kind of approvals from the authorities. So one very, I mean, the most I would say kind of important authority for at least for the whole of the globe is the FDA, right? That's the one which actually is most often thought or ought by companies, by researchers to get the approvals, uh, and because also for the reason that it's kind of not easy to get there, but then once you get the approvals, it also becomes easier to get approvals in other geographies. So having said that, getting an approval from the FDA does not mean that you can start that same process or checks or studies in a different country. Say, for example, anywhere in Europe or anywhere in India, China, you have different authorities for each of those countries also, right? And only when you get these, and there are certain documents, certain proofs that you need to submit before you go in for clinical trials. And in clinical trials, you have different phases. Phase one is basically you want to just go and check onto a very small population of, I would say, healthy people. It's kind of healthy people that you try on. So first thing is not on patients; it's on kind of healthy people, right? Where you know that okay, in the preclinical stage, we kind of did not see any toxicity, any major problems, and so on cell lines or in animals, and then you want to test it on some healthy people, just to kind of make sure the dosages, what's the amount of that biochemical that you need to give, which can be tolerated for a certain body weight. Is it 10? Is it like 500 mgs? Is it like 1000 mgs? Is it like 100 mgs? So that kind of dosage, right? So also things can be like in what form and so forth. And then you go into phase 2 and 3 trials where you go out and test with different population sizes. Sometimes companies kind of do it jointly, phase 2 and 3. They 2 and 3 normally is done to again mitigate risks, to because there is a lot of money and time involved, resources involved when you do it for each kind of number of patients that you do the test on, right? The trials on. So that's why it's done usually in a phased manner. But sometimes, like in the case of vaccine, recently you have seen people go into kind of joint 2 and 3 phase 2 and 3 trials altogether, because they roll it out on a much larger population immediately. So you have something like a expedited process that they follow, and 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 then you go for a submission for an NDA, which is again something like a new drug approval process, right? And the FDA reviews, you get the this thing. And now, what happens during this whole process? This is again a process, of course, that's kind of a mandatory thing, the compliance thing, the legal thing, all this that's there. But during this whole process, at each stage, there's again huge amounts of data again, which is getting generated at the drug discovery stage. That's the part where you get really huge amounts of data, because you have a lot of publications, a lot of information from all sources that you want to go through. People do text mining, kind of try to understand what molecule interacts with what, there are certain pathways, what kind of mechanisms, right? And they do that analytics, and then decide to, okay, let's go into the preclinical phase, because there is only a limited amount of money and resource and time that you want to spend. You cannot just go out and test each and every molecule on all possible cell lines, right? So and that's the also each day that you do, you're kind of publishing results. You're some things that you are actually just kind of uh, throwing it away. You don't even publish. It's maybe lying in some notebook somewhere, which doesn't see any kind of, no discussions, not even with your PhD advisors or your master thesis advisors. You just present what you think is worth presenting most of the times, right? So again, there is a lot of information drop out there. But I personally believe even that is important if we could be capturing it in certain ways, because we know a lot of ways which we know that has failed. We don't need to spend time on, and that's something which no one publishes, right? And again, that's kind of mistakes where not many other people can be making, and again, that's kind of time and resource getting wasted. Now, so that's kind of the data which is getting generated on the leftmost spectrum, right? When we talk about a lot of publications, lot of I mean, what I mean by publications is the research publications, the peer review journals and all. So that's kind of a very important area, which is kind of used by researchers, whether it's in companies or whether it's in academia. They make use of it to design their. It's basically defining the business problem, right? So let's say if you're working on a particular molecule or on a certain pathway, that's that's because a business problem was defined, and that business problem was defined again because there is certain logic, certain publication, some information somewhere published, which kind of backs up the idea that this particular business problem that I'm defining is promising. If I get to solve this, there is some sort of reward that I'm getting out of it. And that's what. So even research problems, research statements that you define, whether it's for your master thesis, PhD thesis, or whether it's for a big pharma company, right? That's something based on certain information that has been collected. So now, so that's kind of drug development process. From that, I moved to because you see how the data is getting collected at different stages. I mean, even though it's a process, but then there are a lot more other ways that the pharma companies or the healthcare industries, right? They constantly keep collecting data from, and that brings me to this slide of mine. So you have many sources. Sorry.
Arunima, can you kindly mute yourself?
Yes, sir. Yes, sir.
Or you have a question, you can ask. That's fine.
Okay.
Okay.
So yeah, so basically that's the kind of data that we are looking at. There are lot many sources, right? So it's not only the preclinical studies, not only the research that's happening in the labs, not the ones that's happening at the molecular level. So it's kind of trying to share my personal experience, right? When I was in my doctorate, I was when I completed my doctorate, and I was looking for certain opportunities into the industry. Often I used to hear industry people talking about, okay, your work is more like at the molecular level, and that's not what we want. That's not exactly what we want. And I was like, okay, then how do I learn your language, right? That's kind of transitioning from academia to pharma. I mean, that's kind of a different story altogether. I wouldn't want to get there. But then the thing is, whatever you've learned, you try to connect that thing to what's there in the world, what's happening in the business. How does that thing actually help the business, right? So you have a lot of government agencies. The one, for example, I mentioned the FDA. You have in the European agencies. You have an agency for India, right? Uh, uh, which kind of approves whether a certain drug can be, or a certain, even a study can be rolled out, right? You have payer records. That's more relevant to, I would, some places like, I would say, US and Europe. Only recently it started in our country, for example, where how the uh, health insurance claims and all are settled. Who pays for uh, your uh, who settles your medical claims, and basically in what respect, whether it's hospitalization, whether it's medicines and whatnot, right? It works differently in different geographies, so that's a completely different, I would say. One could spend like another hour just on that. You have specific sessions for that. Then you have data coming in from smartphones. I mean, you have all kind of sensors: how much you walk, whether it's standing, you're sitting, whether you're running, whether um, uh, you, you have apps which can kind of try to capture all kinds of information, right? From smartphones, we have data when you're using things like UPI, Paytm, right? It's also kind of integrating your financial data. It's kind of it could be capturing your purchasing behavior. It could be capturing what kind of medicines you're ordering, what kind of things you're ordering to eat, Zomato, Swiggy, right? So if you actually see that in an ideal world scenario, one could actually try to integrate that data and see, okay, if this is the kind of spending behavior I have, if this is the kind of things that I eat, and if this is the kind of medicine that I take, are they connected in certain ways? Can we establish certain relation over there, right? So that we can, based on data, unbiased decisions, unbiased insights, can we get into and say, okay, uh, following such and such kind of lifestyle actually leads to XYZ problems in terms of health. That's possible. I mean that's something, in the most ideal case, that we would want to reach there. I think people are already working on that, right? Wearable devices, again, basically, we have devices which can be constantly capturing your blood pressure and your pulses, uh, and there are different kinds of it. How much you run, how much you have sweat out, how much calories you have burned, and all that. You have search engine data, whatever come from Google. So only when I joined the industry, I got to know that, uh, actually, what we do, search on Google, right? That's like manual search. That's kind of organic search. But there could be very specific things that you would want to search in a very automated way on a constant basis. Do you want to put a human there? You could just automate that through scripts, right? You could be doing those searches and pulling the data using APIs. That is possible, but those services from Google are chargeable. You need to pay money for that and get those services. So it's not only advertisements that Google earns money from, or Bing, for example, or any other search engine. Public records, so public records are, again, I mean, they're just a lot of information there, right? Health records, it's kind of, it's not yet there in India, but at least in the US, constantly when the patients visit the doctors, all kind of entries: when he came, which kind of hospital he was hospitalized, whether he just went for an outpatient, what medicines were given. You have the ICD codes, basically, stating whether this person has a pain in the left leg or right leg. That's a different problem in the what kind of a problem in certain part of the body. You have specific ICD codes for that. It's kind of tagging each thing to a data point, right? And that's kind of data that we are generating at the moment, and we are aiming at kind of assimilating that data ingesting it, uh, uh, trying to again analyze that and try to build and connect dots between those here and there, and try to come up with like actionable insights, not just insight, but actionable insights. That's what the industry looks for, all businesses look for. Then research studies, publications, that's again, I mean, I have a feeling that we are sitting on top of a like a gold mine, right? uh, Raghu, just a time check. I think I'm kind of nearing
Yeah,
the end of my talk.
we have about
And
like
also,
3 minutes or maybe like 5 minutes. That yeah.
We had network outage.
okay.
Yeah, we had network
Okay,
outage,
so
so you don't you can extend a little bit more. Yeah.
fine. Cool. So yeah, I'll kind of try to make that a bit concise so that we can still have some time to have some questions at the end, right? Now, now I have some all that data that you have, right? So what do you do with that data again? So these are some problem statements that I mean, typically people associate that with text mining, right? But that's now happening at a more in a more automated fashion. So having proper data structures to it, pulling data in certain ways using something called as ontologies, and so by ontologies I mean kind of word with similar meanings, right? And if let's say if you want to search paracetamol on Google, I would not be interested in paracetamol alone. I would be interested in paracetamol in any drug which has paracetamol in it. So I would want to see all the records, all the search things, which includes both, not both. I mean everything which is around paracetamol. So let's say it could be crocin, not paracetamol. But I have not searched for paracetamol. I would want to see records for crocin as well, because crocin is essentially paracetamol. So, but then again, I'm deviating in interest of time. So, drug repurposing is something like we have a existing drug, right? And we want to see if that drug can be reused for a different indication altogether. That's possible. Often, one particular molecule can be used for a different. I mean, not very often, but yes, often it can be used for a totally different disease. And in that case, what happens is you don't need to go for preclinical studies. You don't need to go for the clinical phase 1 trials, because that is already checked and done. Because maybe you want to see that kind of dosage, obviously, and then how it is effective in that particular disease in that kind of cohort of population which has the disease, right? And then you go for that approvals. So that happens very often in pharma. Drug prioritization is like, let's say this drug can be repurposed for more than one disease. Which disease you should choose, because you might have limited resources to follow up the whole process. Limited resource in terms of money, time again. So you would want to choose, okay, this drug can be is possible to repurpose for disease A and B, but should I choose A or should I choose B, because that's the only limited time and money I have. Then you would want to go and see, okay, what's the probability that at the end I get an approval for whether I'll get an approval to sell my drug for, is it for A or is it for B, right? That's prioritization. Then I mean drug molecules, again, drug discovery process. Maybe I'll not go in detail there. You know some things about it, even though there are more advanced ways of doing that using NLP, entity recognitions, embeddings, and all. I mean that's very interesting topic. Again, in sake of time, I'll skip that. KOL identification is something like you want to know about who are the key opinion leaders for a particular disease. Let's say in terms of in India, who is the best cardiologist, right? So that he is the most important key opinion leader for in terms of cardiology in India. Can we find them? Can if we have that, can we? So if we have them on board, if we want to do certain clinical trials for a drug on cardiology, can we have them there, right? So that's kind of thing we want to identify based on those analytics. Can we identify some people who are budding like a superstar kind of thing, person who in that area, who is new to that area, like a budding scientist, or in research we call them as young scientists, right? Young researchers. Can we find them in the beginning and kind of get them aligned on board with us during the journey? And predicting clinical trials outcomes is something again similar to what we also try to use in drug prioritization. That's again happening using NLP and advanced techniques. You categorize the variables, you design the variables, like what are the outcomes of the clinical trial, primary, secondary, and so on, whether it was successful, what kind of population size you had used, what geographies, what locations, what kind of hospitals, what kind of PIs were involved. All that information accumulated, you design features around it, you run that models over it, and then say, okay, this is what I want to do, and what is the success criteria, what's the possibility that this particular thing will succeed or not. And then based on that, there's a lot of money involved. There are a lot of hedge fund companies, the finance companies. They actually go out and hedge money in the stock market. Okay, this company is going for a clinical trial for so and so drug. Will it be getting approval or not? And if the clinical trial predicts it well, what happens? You can, and if that's a good engine, good model, you can believe that, you can put your money on that, and if the trials get approved, you can believe what happens next, and what happens actually if it fails, right? So that's where it's important. Now that's the kind of important, I mean, some of the problem statements that we have in the industry that we solve. And coming to the end of my talk, these are the key takeaways from the talk that I have. Big data, as to what I see, is a big opportunity, and in a different way, it can also be seen as big challenge, because I mean, opportunity, responsibility, anything comes with accountability and a lot of obviously challenges. You need to, it's opportunity, but you need to kind of manage that. Managing the big data is a challenge. Making use of it, having the right skills, right people, right resources to be able to use it, right? And that's how basically it helps the businesses, the ventures. Even if you know how to make use of the big data, the technologies around it, that's how can be useful for getting jobs. And if you, I mean, everything is connected, right? So that's big opportunity that's out there using big data. All these technologies that I even shown with the example of Amazon, Google, and Microsoft, these technologies are very dynamic. They keep evolving, right? And we need to keep kind of up in pace with them, how they're evolving, what's coming up new. If there is something new that can solve a particular problem which was not being able to solve earlier. I mean, now we are able to kind of process huge chunks of data because there are certain technologies in place. Imagining to do the same thing like 10 years back would have been a huge challenge, right? So that's how that's also kind of helping us. And because we have these things in place, we are able to completely redefine the solutions of and the industries. So now we're talking about, can we reach to double the number of patients in half amount of time. So like kind of reaching 4x of 4 times the effectiveness of the business that's happening. That's kind of question that we're looking at. We are trying to solve, and at the end of it, that's a very important thing. I mean, and that's one again, even though it's the last point, but it's not. I would say it's not the least. On data as to what I see today. Uh, earlier was it was earlier it was as a means of creating asset, but today data itself is an asset. Data itself is the new commodity. It's the new oil. It's the new real estate. So having the right data is like having your stakes in the real estate today, and having it, and further knowing how to make use of it is again. So one thing is you have the bricks with you, and then you know how to make a house out of it, right? So that's the real estate I'm talking about. So these are the 4 key takeaways from my talk today, and I come to the end of my talk. And thank you for your patient hearing. And I'll take up some quick questions.
Thanks, Anurag. That was a really great talk about laying the foundation for the theme for today. I have one question. So this is like from the perspective of if I was a student entering into big data, and so what are the kind of like, are there some kind of do's and don'ts that you would talk about, or something I should keep in mind?
Sure, I think that's a very good question, Raghu, because that is something which was also constantly back of my mind, right? 15 years back, uh, uh, I mean, when we were together in JNU, the things were very different. I mean, the way the kind of view that I had about industry and things work, that was very different. And having made that transition also was not an easy journey, right? So I can share some of my learnings from there. So anybody who wants to enter big data in whatever respect, whether it's biology, somebody coming from a commerce background or anywhere, right? My only advice to them would be just go out full throttle. Don't have any hesitations. It's big data, but it's not a big thing. I mean, I'm kind of contradicting my own statement, but it's something which anybody can do, given that he has spent the right amount of effort and time. What I've often seen from students from the biology background, they are often afraid of even trying it out. And on the contrary, I've also seen people coming in from purely pure biology background, but then they have picked up programming and a bit of statistical understanding of stuff, and they are very good, I would say, modelers and making some predictions and helping the business, right? And and so getting into big data is it, I mean, it's a process, it's eventual. So getting into big data is, I think, it's the kind of the hope, the motivation that should keep you kind of running there. If you know that by getting into big data, even from the background that I have, because that background is also that's going to help you. So somebody coming as a pure engineering, just doing that big data thing, right? He has a different understanding of the whole thing and different way of looking at it. But let's say if you are doing it yourself, that whole managing the whole data, and you know the biology behind it, you look at the same problem, the same thing, the same solution in a different way, because you know that this is how I want to consume the data at a later stage. So you design those solutions right from the beginning in certain fashion, right? So it's about having that bigger perspective, knowing the domain, and so you know the domain, and you know that technology, and kind of fuse it together, and that sum is not 1 plus 1 equal to 2, but it's 1 plus 1 equal to 11. That's kind of synergy it plays. So have that confidence, have that belief in you, and you can do it.
Okay. Thanks. Nishka has asked, is PhD necessary for biologists to enter big data biology industry?
um, well, frankly speaking, that is not necessary, right? um, but then if you talk about the pharma industry in specific, right? um, Having a doctorate or PhD in a certain subject, right? And especially, let's say if you're going in terms of big data, right? There would be kind of limited opportunities where you'll be actually using that pure bio kind of background thing in there. But it's more of the understanding the mechanisms, the underlying basics of the biology that we'll be using there. uh, so if I have to answer that in a yes no kind of thing, no, it's not absolutely necessary, but it does help in certain ways. when I say it does help in certain ways, is that it gives you a broader perspective of the same problem that you're trying to solve, as compared to somebody who is a pure technologist. So that's my take on that.
Okay, thanks, Anurag. Aishwarya has asked a very specific question related to jobs. What is the scope to get jobs in R&D field in Novartis?
Well, yeah, I mean that's kind of a question which I keep getting from students and people often, and I know that everyone after the studies would be looking at the outlooks, going out in the world and joining some good companies and contribute their time and effort and also helping the development of the business process and all that. So specific to Novartis, right? Um, I think there are different ways of it. I mean, many of them would be common and common knowledge. I mean, obviously, going to job sites and it could be Naukri, Monster, whatever, and through consultants, job consultants. But at least when you talk specifically to Novartis, at least from Novartis' perspective, what I do know is that that the Novartis job portal itself, that's the main company website, that's quite useful. It's not like sending your resume in like a black box and you never hear it from there. At least from companies like Novartis, the job portals are a very good place to send and actually go out and look what kind of position looking for and apply there. Other thing which often works is through certain references. So if you are uh, if you know people from the industry, if you can get to connect to them, if there are certain ways that you can uh, uh, reach out to them and kind of send your CVs to them. Even at that time, they may or may not forward it directly for obvious reasons that they may or may not be involved in that process or know that hiring manager. At least they can tell you about the process. Sometimes it helps to get direct interviews also. That's purely based on the capability of the candidate, the kind of the requirements and all that. But yes, references do work sometimes, many times actually. So it's kind of mix of both. So you can follow any of those ways. So go through references, go through job portal, um, and so by one thing one like a star there, going through references doesn't mean that you're getting hired. Only thing is that uh, given that your CV is competitive as compared to the other candidates, you just get a chance to get interviewed. And after that, everything depends on the capability and the ability of the candidate himself or herself. So
Does
does that
anyone
answer your question?
else has any other question for Anurag? You can unmute and you can ask.
Sir, I have.
Yes, Shankaran, go ahead. Yeah.
Yeah, I have a question. So you were speaking about the clinical.
Can you be a bit louder? You're a bit feeble.
Oh yeah. Now, am I audible now, sir?
Yes.
Okay. So you are
Yes,
speaking
Ankaran.
about the clinical trials, right? So there you are mentioning that initially the drugs will be tested in the healthy individuals, and at the later stage of the clinical
Yeah,
trials, it will be tested in the diseased patients, right?
right.
Yeah. So I have a question there.
That's right.
So when we say diseased patients, what are the kind of diseases we'll be mainly focusing? Because I assume that it is not possible to cover uh, every disease that exists in the world. So what is how will you channelize the diseases? Whether it depends on the product that you develop, or uh, say obviously we I understand that there will be focus on the diabetes and the heart problems. So how will you channelize
Mhm.
your testing on the certain kind of diseases?
Okay, okay. So to address that, number one, so any clinical trial, right, that happens in the world, that is always specific to a particular disease and a particular molecule, right? So that's a combination which is out there already right from the inception stage. So I want to correct it there, because at least in the preclinical stage, you may not be knowing that particular molecule will work for a certain disease or not, right? Because only from the drug discovery phase, you might have indications. Okay, this molecule is responsible in a certain pathway, right? And this pathway is responsible for a certain disease, right? So then that kind of gives you a mapping. Okay, this A implies B and B implies C, which means A is kind of connected to C, right? And based on that concept, you go into preclinical stage and test out, okay, if I give this particular molecule to this particular cell lines, or this particular mouse with this kind of problem, does that impact the mouse? Does that impact that animal? Right? So then we know, okay, if I give this kind of this molecule to this mouse or mice, um, that's actually leading to decrease in blood pressure in the mice, right? So even at that stage, we know that this drug is kind of working for
Okay.
that kind of indication, right? That disease. So and then when you go into when you have done those all that studies, and when you try and get into the clinical trials, you know that you will be testing that molecule for blood pressure alone,
Mm.
and you'll be not testing it for something else.
Mm.
So the disease is kind of already known from before, right?
Okay.
And then you start into healthy individuals, and that's with the aim that you want to finally go out and roll out a drug which works for blood pressure, right? Because you know this molecule, but you cannot just go out and test that drug for example, uh, cancer, because there are no indications, whether in literature or through your cell line studies or your preclinical studies, that indicate that this molecule will work on cancer,
Okay.
right? So that's how it is. So you know it already kind of predefined in that, and then you go and do it accordingly. And but then yes, there could be certain cases where you know from the literature, from the research, whatever data analytics you've done, you know that this molecule is kind of a master key, and this could be opening up more than one doors,
Okay.
right? This could be good for, this molecule will help you in kind of allergies, immunotherapies. This molecule also help in anti-cancer therapies. So this is like a very potential molecule, right? So in that case, what will happen is, again, you will try to do a drug prioritization.
Okay.
Prioritization is, again, so if you have the money and you say, okay, this molecule can open up two different doors, and you have the money and resource, okay, we don't want to waste time, let's spend the money, open up two paths, two projects, define two projects, and boom, it goes. One path will continue the clinical trials for immunotherapy, the other will continue trials for anti-cancer.
Okay.
And again, a very specific kind of cancer, again very specific kind of allergic things, right? And then it goes. But let's say if you have limited on funds and money and resources and time and people, right? What you would want to do is, you want to see what are the possibilities that this particular molecule will get to the final stage of approvals for allergy, or whether it gets approval for cancer.
Okay.
And that's not only on the basis of what the FDA will approve. It's also on the basis of, do you have the right skill set? Do you have the right people? Do you have the right team? Do you have the right geographies where you can get the right set of patients that you're looking for? All those things go into account. Based on that, you do the prioritization. And then you say, okay, I don't have enough patients or enough people who can do the research or things for allergy or immunotherapy. I have more number of options, more possibilities, more grounds that I can cover in case of cancer. Let's say breast cancer, for example. Then you would say, okay, let's go out and do the studies and clinical trial for breast cancer alone. And that's what you will file your the investigational new drug application for.
Okay,
So
thank you.
does that kind of make clear or answer your question?
Yeah, exactly. So I have another question too. I hope I'm not consuming more time.
Yeah, Shankar and Ashita also has asked one question, but then we have a
Okay,
session
okay.
starting at 11, so we have like it's 10:50 already.
Yeah,
Uh,
okay, sir.
what
Understood.
I would recommend is Anurag, is it okay if participants can contact you post the workshop and ask you about specific queries?
Yeah, I would be happy to do that. You can reach out to me on LinkedIn, and that should be perfectly fine.
Okay, so what I'll do is I'll share your LinkedIn profile to the participants. They can connect with you via LinkedIn, and then they can ask the questions that they've asked here, right?
Thank you, sir.
Okay, sounds
Sure,
good.
sure.
Okay, with this, I would like to thank the speaker, Dr. Anurag, for giving an enlightening talk. And I'm sure, just like me, everyone has heard what the industry perspective is and about big data and setting the stage for today's session. The next session is from the School of Computing, Dr. Subramania Swami and Dr. Ilakya from Shastra deemed to be university. They will be talking about. I'm sorry, I'm blanking a bit here. But yeah, so what we would be doing is we'll not be connecting to any of the Windows or the Linux systems. So they will be showing you some tools which you can connect directly from your laptops to the browser, and you can concurrently do them. So we'll see you all in another 10 minutes, and after taking a small break. So thank you, Anurag, again. Thank you for taking time and explaining everything to us. Thank you.
Thank you, Raghu, for having me. It was really a pleasure. Thanks a lot.
Thank you. Yeah.
Thank you.